Hi, okay, this is a video of the issue with the micro-op port of dcache MMU and load store in libre-soc, and we encountered a an overlap bug. I just wanted to go through it. So you should be able to see the cursor here. Let me just drop a marker on that one. Here is where the page table walk is taking place from the cursors at the top of the screen here. Let me zoom in. Here's the page table walk, and these are reading the leaf nodes of running under Linux 5.7. So you can see the addresses and the leaf nodes, and the top is C0, which indicates that it is valid and a leaf. Now, let me scroll down. That's our stack of things for the dcache. Basically, what I've got here is I've created an emulation of block RAM, BRAM, in C++. So it's this is a fake memory implemented in 512 half a gigabyte actually in C++, which is accessed via the wishbone bus, and this is this one here in purple is the dcache reading from that. So that's all expected. These ones in green here are the UART when I was having a look at that. And now here we've got the dcache in done and error. All right, so that's done. So this, let's have a look. Let me see if I can find the relevant things. Oh yes, here we go. In the purple here, that's the page table entry, which was, and that is in the MMU. MMU is looking at that and decoding that page table entry. So that indicates that it was done. mout was done, and that's the signal for out from the MMU to dcache was that operation there. This one. Now you can see here this next one. It's doing we're getting this next cycle here is the page table entry. The TLB load is being pymem.dcache. So the dcache is being told by the MMU to do a TLB load, and it says, yep, here on this cycle here, it says I'm done. Then where was it? Where's the D valid? And there's a next. Yes, here we go. Here's the D invalid, the valid one here. All right, so dcache in valid. So from that's that cycle there. That's that third line there. All right, so at that point, it's going through and it's asking for the store st store double word to take place to continue now that the page table entry is valid. Now, the problem comes when if we look at the forward row here. Here, when that same tag thing, where is it? State r1.state is idle there. so um, uh, the the MMU asking dcache to begin this particular cache line fill, and that starts there, and that 01 is a reload ACK wait, which does not end until this cycle here. But notice that all of that time it was still we had the request for D invalid. D invalid requests the to continue the to do that store again once the page table entry had been entered. But we're still in reload wait ACK in R1. And the reason is because the strobes, we've asked it to, they were still in the, still reading the eight page table entries into the cache line. So that's the source of the problem. Is that this is basically this this D invalid. If that was another 5 cycles later, it would be fine. But the problem is, as you can see, R1 full is 0. So it's an R0 full is 0 thing. So it's perfectly legitimately quotes legitimately saying, oh yeah, nothing's full. You can start this. Yeah, I'm not processing anything. Sure, certainly, sir. Sure you can do the. You can ask me to do this the store, despite the fact that R1 state is in a reload wait ACK, and that's basically what the problem is. If the R1.full stayed full until right the way to the end of the load from the strobe. So have all this forwarding, these forward row things, these things here. Yeah, it would be fine. You'd finish the reload wait ACK state and then move and then start processing the thing. But then you have a conflict of you couldn't answer the R1.full is the sole indicator to say that the MMU that the results are available, but that result was from forward row. Which one was it? Forward row 2. That was that result that was returned with the page table entry, which caused the dcache PTE lookup, caused the MMU to put the page table entry in, was back at ACK number 2, ACK row 2, and it's still doing 3, 4, 5, 6, 7. Despite sort of things, so R1.full was set to 0 at ACK 2, row 2, but which then allowed the thing, whilst still having R1.state equal to 1, which is the reload wait ACK, whilst having the thing. I mean, you get the idea. And the temporary hack that I'm putting in, trying out, is that if it's an MMU request, R1.full is not set until the end, but until right at the end, R1 is full is set by when idle is set, but not for load store. So load store can continue to do this trick of answering early, but MMU requests can't. And I just want to see if that quick hack fixes it, because previously when I tried to delay this R1.full for both loads, for both load store and MMU, it definitely didn't work. So we'll see how that works out. All right, cool.